So if you read this question, first of all you go to your claim, right? That's the claim that the standard deviation. Okay, you got that. So that's where you put standard deviation 1 and standard deviation 2. And then read again, standard deviation of this is different from, that's why you have not equal to. So this is your original claim, the one for your claim. And your HO is just the equal sign.
And I did get that part. Okay.
So whenever you have standard deviation test of two populations, you're gonna right away use two sample F test. Remember that. So whenever it's about standard deviation with two populations, it's always about F test.
Okay.
So in F test, it's now you can either use the calculator right away or find it manually, right? So if you want to find it manually, the best statistic F test is equal to the sigma 1 squared, sigma 2 squared. And you're gonna get the answer. The same answer with the if you do this one, two sample F test. So after you do that, you have to find your critical value, right? Your critical value is still the same thing. You're gonna use your alpha and H1 just to show it's two-tail. Okay, it's two-tail. It's two-tail. And then now you use your alpha. Alpha is 0.05. If you divide it by 2, you're gonna have 0.025 here and 0.025 over here, right? So since the table of F test, which is A5, this table F is taking area in the right tail. So if you look at your graph again, area to the right tail is 0.025. That's why you're going to use this one. And then for this table, you're going to use degree of freedom 1 and degree of freedom 2. So degree of freedom 1 is n minus 1, right? n1 minus 1 is 30. And n2 minus 1 is 40. So you go to 30 and then go down to 40. You get this number 1.9428. 1.9428 is your right critical value. That's the right side. The left side is just 1 over the right side. 1 over the right side. So if you put in the calculator,
over 40, would that be it?
No, you do this number.
This one would be in the calculator.
1 over 1.9428. So you got 0.514. Okay, so
he has a 2 0089.
Okay, forget about that. So this one, the right side is so your left side is from 30 and 40, right? That's why you got 1.9429. Right, 30 and 40. Over here, you have to do 1 over F. Instead of 30 and 40, you have to do 40 and 30. So 40 and 30. So you put them like on the other side. So you do 1 over that. So put it in the calculator. 1 over 2.0039.
0039?
89, sorry. If you
0.49778.
So that is your left thing.
Okay.
Critical value left, critical value right. Okay, let me repeat it one more time. First, you draw it, and then you decide if it's two-tail or one-tail, right? Because H1 is not equal to, then you have two-tail. And then you're going to use your alpha divided by 2 because you have two-tail. So you got your area to the right of this point is 0.025. And you're going to use this table. You know you're going to use this table. So the first step is to find the F to the right F. The right F, you take the degree of freedom 1. So 31 minus 1, you got 30, over degree of freedom 2. Like 41 minus 1, so you got 40. So you go to the table and find 30, and then go down to 40. You got this number over here, 1.9429. Right? That's your right side. If you want to find your left side, you have to do 1 over, instead of F 30 and 40, you flip them. So it becomes 40 and 30. So 1 over 40 and 30. F 40 and 30, you got 2.0089, right? You have to do 1 over that to find your left side. So 1 over that number is 0.4978. So that's your critical value left. And that's your critical value. And then when you do the calculator, you're going to cut your p value right away.
Because we would have got that back over here when we ran the test.
Yeah.
Right.